Okay, this is day 16, Monday, April 20th. I'm going to start with the last homework problem from last week's assignment. The reason I'm doing so is because I really kind of wanted it to be on the interval from 0 to 360. You probably did it on the interval from 0 to pi, which is fine. So I said to use a calculator, but first let's look at this before we even grab the calculator. We're looking for the inverse sign of a negative number. So where are we talking about? We're talking about the sign being negative in the fourth quadrant and third quadrant. So if I would take the inverse sign of x of the inverse sign of negative 0.73. If I'm in degree mode, it's going to give me a negative 46.6. No, negative 46.9. All right, and then I'd be over here. And again, that's a reference angle, so it's not. But that's what the actual calculator gives me. That, if you recall, I talked about there's three ways of writing these answers. Principal values on a set interval is what we're doing here. And then also for the infinitely many answers. The only one I'm interested on right now is here. So we're going to do the same thing. We're going to draw our x and y axis. We're going to put in the reference angles in the quadrants where it is negative, and then come up with what those angles are. So if I go ahead and take 180 and add 46.9 to it, I'm going to get 226.9. And I'm also going to get 360 minus 46.9, which gives me 313.1. So the negative 46 that came up in the calculator is not an answer because negative 46 is not on the interval from 0 to 360. The two answers that give me my reference angles of that 46.9 between 0 and 360 are the 226.9 and the 313.1. If I would have done the same thing and had my calculator in radian mode, this one should be equal to here. Well, that's going to be 6.28. So you can just think about this, that this is 3.14 or pi. This is 2 pi or 6.28. Of course, up here is pi over 2, or about 1.57. And down here is going to be 3 pi over 2, or about 4.71. So when I do this in my calculator, the x equals the inverse sign of this negative 0.73. X is equal to a negative 0.66 radians, not negative 46.9 degrees. So I'm going to do the same thing. I'm going to go ahead in here and put a 0.66 because I know that the sign is negative in the fourth quadrant. I'm going to come over here and put a reference angle of 0.66 because I know it's also negative in the third quadrant. So I'm going to do the same exact thing. I'm going to take 3.14 and add 0.66 to it. And that's going to give me 3.8. And I'm also going to take 6.28 and subtract 0.66 from it. And that gives me a 5.62. So whether I'm dealing in radians or degrees, it's exactly the same. And we did the same exact thing with special angles. We didn't have to convert to the 3.14 here. We may have had a pi over 3 here. So that would be 4 pi over 3. It's the same process that we're looking at here. Okay, well, I hope that helps with the homework. We're going to still be solving trig equations. We're still going to do it on the interval from 0 to 2 pi. We might go ahead and change that interval, but not today. I just want to keep practicing this. It's not the easiest thing to get. It's just really the unit circle, though, in reverse. So basically, my x is here, so it's a sine of x. So I'm just going to subtract 3 sines from 5 sines. That's going to give me 2 sine of x. So we're just isolating the variable as we've done with equations for numerous years. And I'm going to divide both sides by 2, which is going to give me a root 3 over 2. Now, how do I free up the x here? Well, of course, I'm going to do the inverse operation, which is the inverse or the arc sine. And if I do it to one side, I've got to do it to both sides. Well, the inverse sine of the sine of x is just that. It's x. And that gives me then the inverse sine of root 3 over 2. So now we're right exactly where we were on last night's homework, or last week's homework. So again, the inverse sine is going to be positive in the first and second quadrants, and that's going to give me a reference angle of pi over 3. So I've got a pi over 3 in the first quadrant. I've got a pi over 3 in the second quadrant. So the two values that solve this equation are going to be x is equal to pi over 3 and x is equal to 2 pi over 3. And that's really all there is to it. But a couple more examples here. The equations get a little more difficult. Okay, the second equation I'm going to do is this one here. And it's a second degree equation. So all I got to do is set it equal to 0. And this is going to be a little funky for some of you. I'll write it right next to it a little differently, and hopefully it'll make sense. But let's just go ahead and set it equal to 0 first. I'm going to add the 1 to both sides. And now I got to factor this equation. So I'm going to have two factors. 2 sine x squared. That can only come from a sine x and a 2 sine x. That's the only two possible factors. Multiplying those together gives me 2 sine x. Well, 1's easy. It's prime. It's only going to be 1 times 1. They are the same sign, and they are both negative. Or you can look at the inners giving me negative 2 sine x, and the outers giving me negative sine x, and there you have it factored. Now, if you see this, just help yourself. That is 2x squared minus 3x plus 1. And all I did is let x equal the sine of x. And I know everybody can factor this guy. You're going to go x, 2x, minus 1, minus 1. I forgot my x there. And then you can just replace x with what it is, sine of x, and that will give me sine x minus 1, 2 sine x minus 1. Well, like any other quadratic equation, once it's factored, we're going to go ahead and take this equation, sine x minus 1. We're going to take each factor, set it equal to 0. And now we just have two problems. I'm going to add the 1 to both sides. So sine x equals 1. Take the inverse sine of both sides. So x is equal to the inverse sine of 1. I'm going to add 1 and divide by 2. So x is equal to the inverse sine of positive 1/2. Okay, so where does what angle has a sine of 1? And there's only going to be one of those right here at the 90 degrees, or pi over 2. So x is equal to pi over 2. All the other ones had 2 solutions. Well, this one's a little unique. It has 1. That can happen. And over here now, where is the sign positive? The sign is positive in the first and second quadrants, but it's going to have a reference angle of pi over 6. I think the last one we did was a pi over 3. Pi over 6. So x is equal to pi over 6 and also a 5 pi over 6. So this equation has 3 separate answers for its solution. Okay, the third and final, and 3 examples might not be enough, but after you check Google Classroom for your homework, please keep asking me questions. I really am not getting as many as I think I should be getting, but keep them coming. Not a quadratic equation, but I do see 2 signs in 2 different terms. So what I'm thinking is I need to get those on the same side and factor out the greatest common factor. So now I see the sine in 2 different terms. So I'm going to bring the sine x out, and that's going to be multiplied by the tangent of x minus 1. Okay, again, 2 factors that equal 0. I'm going to set each one equal to 0. The sine of x is equal to 0, and the tan x minus 1 is equal to 0. Take the inverse sine of both sides. X is equal to the inverse sine of 0. Okay, oops. 1. No, that is just 0 there. So the inverse sine of 0. Thinking about the solution. All right, now where does the sine, or what angle has a sine of 0? Well, there are going to be two of those, over here at 0 and over here at pi. So x is equal to, now we got to check our interval out. 0 is included. So yes, it is 0. And of course pi. And I don't include 2 pi because it's not included. And that's why this interval, the only two solutions. So if I were to give you the infinitely many solutions, that is on a straight line. So I can say x is equal to, and this will look familiar to you, x is equal to 0 plus, and from here to here is pi, another pi. Every pi I'm going to get a solution. So 0 plus pi n, where n is an integer. Just throw that in here now. That's where we're going to go. We're either going to give it an interval notation. Given an interval, we'll give the answers on that interval, or we'll give the general form of it, or what's called the principal values. And the principal value answer for this one would be 0, because the principal value is either going to go from pi over 2 to negative pi over 2. Remember that negative 46.9 we got? So it's either going to be from positive 90 to negative 90. That's for the tangent and sine. Or from 180 to 0 for the cosine. Those are the principal values. Again, I'm just throwing that out there now. If you want to put it in your notes, that's great. I'll deal more with that in the next couple days. All right, well, we're not done with this problem yet. We got the tangent of x is minus 1 is equal to 0. So I'm going to go ahead and make that tangent of x is equal to 1. So x is equal to the inverse tan of positive 1. Now, where is the tangent positive? The tangent is positive up here in the first quadrant and down here in the third quadrant. And of course, we know that the tangent is 1 at pi over 4, 45 degrees, pi over 4. So my answers are pi over 4. And in the third quadrant, I'm going to add one more pi over 4 to 4 pi over 4, or 5 pi over 4. So there are my 4 solutions to that. All right, guys, well, I hope that helps you. Hopes you get your homework done. I will post it on Google Classroom. Please keep asking the questions. Keep them coming.